All right, it's a bit windy, but we are there. You can see my son is crawling and laying the wire underneath the solar panels. So it's that red wire. Let's quickly get up there. And there's the red wire, the positive wire that strings the whole thing. Right, so all 10 panels will then be in series, and then we installed just a nice little pipe here that keeps the wire neat and tidy, protects it. You can see this is a very old building, but we're bringing it into the wall here, straight through into the inside and then back into the garage. And on this side we've got the negative side also, so the negative will be here, this shortest cable. And that's how we get the cabling into the building. Alright, so here you can see the bracketing system. It's got a little grommet that goes into the roof or onto the roof, sealing the hole. That's why you have to drill a bigger hole. I think the hole size on this is about 14. I drilled a 13 millimeter and then 7 millimeters into the wood, and then I just put the hanger bolt in. The hanger bolt uses a little Allen key type of a socket, so a hex socket to drill it, to drive it in. And then you've got that L bracket, and that attaches easily to this rail. And then on the rail side, clamping the panels to the rails, we've got this end clamp, and in the middle of the panels we've got this middle clamps. So all of that is like a quick connect kind of a system. And these you have to tighten. I think that's 12 Newton meters, and this one will be 9 Newton meters. Don't over tighten those. And that is already a lot tight. Tight enough. Don't want to tighten aluminium and glass more than that. In any case, that's how they look up here. All right, so here's what I've done so far. The inverter has been installed on the wall. The brackets attached there. Just placed these stickers that you get with on the system, so that everybody just knows what this is. Also on the cover plate, there's a warning sticker that tells you that it's a solar system, dual power supplies, or whatever. So here's my logger, and it's doing its thing. It's connected to the Wi-Fi and sending information back and forth. For now, this cable, it needs to go into an isolator. So it is actually into an isolator. I've got a very old house, and this box that's actually my main breaker. I'll replace that soon. But this is now actually my main breaker for the house. So that will be, and this is earth leakage, but also the inverter's power. So this actually serves as an isolator also, and that's just a breaker for the inverter. So the CT clamp is here from the meter is actually on the other side of this cable. First thing I did when I connected the inverter is connect the earth wire. So there's an earth wire connected to the inverter, and also inside here everything is earthed, and the live and neutral there's the CT clamp connected. So this is a grid tied installation at this stage. I can't afford batteries right now, but it's night time now, so the DC light is off, AC is normal or on, and no alarms, so that's good. So I did put a sticker also there that shows that this is the place where you can just for emergencies disconnect the inverter. Oh, the solar that's on the roof is coming down in this pipe, the DC, running into my little DC array isolator whatever box. These are actually just fuses, so because it's nighttime I can just open this and show you. Little 20 amp fuse there, and yeah, the positive and the negative one has got a fuse on there, and there I just put a sticker that it's 1 and 2 and 3 is the solar PV ones, positive and negative fuses. So this little box is just for the DC part of the thing, and then it goes with a cable, and here's also labeled. This should be still, I should still attach this to the wall. This is a little sticker that I just put on that just tells you that you shouldn't disconnect the cables here, because there is actually, there could be load on there if you didn't switch off the isolator. And yeah, I think that's it for now. My next few panels will be connected there, and yeah, I'm happy. And yes, I'll just show you in the daytime how much power this thing delivers. It's quite a lot. The array on a cloudy day was close to 3,600 watts, so actually it was 3,600 watts, and I think the array is it's maxed out at 3,750 at the moment. So yeah, this is just giving me lots of savings at this stage. I will get to the battery part. I've got a lot of space here still where I can install a battery cabinet, whatever, and yeah, just move all this junk away. Right, so everything's connected. I have a tumble dryer that's running at the moment, so let's just quickly see. We've got a very cloudy day, but sometimes I say that's better, but let's just see. Right, so now because of the clouds, we'll see when the sun comes directly through the clouds. You can see it's 1,570 or 590, almost 1.6 kilowatts. So we can just wait a bit maybe for the sun to come through, but as you can see, the house is drawing 4.3 kilowatts at the moment. And right, we'll see. I'll quickly wait for the sunshine just to come through the clouds, bit of open sky, and then I'll be back at this screen to show you. All right, there we go. Sun is just popped through. The clouds is in and out all the time now. So there you can see it's dropping away again. Massive cloud going in front of the sun now. It's actually insane. I can hear on my roof. I can hear the sun coming through. All the plates and everything is crackling and making noises. There we go. We're almost at maximum capacity. 3.6. Excellent. 11 amps. That's what we want to see. Great.